We are here from DeepSQL, the world's first adaptive database. It also has an R-rated personality mode if you want that. We are a local company here in Boston, just down the street, in fact. Been around about 5 years. We closed our Series A last year. We launched the product about a year ago. It's a subscription-oriented database model, so it's targeted for easy consumption and obviously anticipating large movement to people deploying applications in the cloud. And we offer options for both service providers as well as enterprise users. So what is this DeepSQL thing, and what does an adaptive database mean? So first off, it's a MySQL compliant system. So I'm sure many of you have heard of MySQL. If you've ever heard the term LAMP stack, which virtually every website is built on, N is MySQL in the stack, so it's pervasive. I would venture to guess that almost everybody in this room probably has a MySQL-based application or dependency somewhere along the way. So our solution is designed to drop into any existing MySQL environment, no code changes required. The big difference is MySQL, as is the case with most databases in the market today, is based on 40-year-old computer science technology. We reinvented that, and we came up with an approach that uses at its core an adaptive machine learning algorithm. And what does this mean? Well, it really means that we're able to observe the actual work that's being asked of the database and the ability of the machinery to carry out that work. And once we have that information, we then can predict and schedule as effectively as possible the resources available to get the most possible work done. Sounds simple, and it is. It was hard to build, but it's actually simple to run. Beauty of it is it runs itself. And that's a big departure from traditional databases, which require a lot of human intervention in order to kind of optimize them. So what's the value look like? So if you look at databases, and you heard Mongo mentioned earlier, we have NoSQL, New SQL, Old SQL. Well, the reason you have all these different flavors of databases is based on that old computer science. You could build a database that was really good at a certain workload. It might be really good at transactions, for example, or it might be really good at analytics, but it generally can't be good at both. We break that rule. So the two iChest charts up here, sort of the one that's on the upper left, is a transactional insert heavy. Think like an Internet of Things type use case. And we basically ran the same machine, once with standard MySQL and then once with our DeepSQL product, no application changes. And you can see about a 64 times faster throughput on transactional work in this use case. The lower right-hand graph is an analytics workload, which is doing classical business intelligence type queries. And you'll see a 2 to 3x improvement, again, without changing a single line of code, same database configuration. Nothing's changed but the workload. But because our system is machine learning, it can recognize the work being asked and schedule at a sort of a very minor or micro level. So, think about like a car has an engine computer that's constantly monitoring the best mix of gas and air and spark timing based on the workload being asked of that engine. We do the exact same thing in the database. So the net effect of it is you get a lot more throughput on the existing system. One of the other cool things that we do is we really try to anticipate where things are going in the cloud. So in the cloud, you might fire off an instance of a database, and Monday through Friday, you're able to get on with this machine. This example is 4 cores, 16 gig of RAM, and everything's great. But as the user load starts to increase, let's say we're getting close to Black Friday or Cyber Monday, as the users increase, the delays get worse and worse. In the old school, you'd have to fire up a new machine, take down the old machine, migrate your data, and bring it back up. In ours, and because of new cloud technology, on the fly, you could just simply go out there and add more CPUs and add more memory to these virtual machines in the cloud. The problem is, traditional databases don't know that it happened. They don't know what to do about it. In our world, because we're continually monitoring and learning and adapting, we detected that there's more resources. We make use of those more resources. Cyber Monday ends, it's boring Tuesday, those resources go away, we'll scale back and reschedule our work accordingly. So this gives you complete and true elasticity in the cloud without abandoning or having to move away from the MySQL environment that you're familiar with. Now, it's just not about benchmarks. I won't go read through all the charts here, but I took a sampling of our customers to showcase that across different industries and across different workloads, they see compelling performance gains without having to change a single line of code. They didn't change their application one iota. They simply replaced MySQL with DeepSQL and saw bigger, faster, better solutions. So from a top-line perspective, our advantages are it's MySQL, so you don't have to change anything. But it makes MySQL better, it makes it faster, it makes it more dynamic, and it allows you to make your application, as you add new features and benefits, the database will evolve to take advantage of those new capabilities. So that was it on slides. I'm happy to take questions. Yeah. Yeah, so the question was, how much does it cost? We offer a couple of different licenses. So for development, non-production use and trials, it's free to use, unrestricted, no limits on size, features, or anything. For commercial deployments, we have enterprise pricing that starts at $2,000 a server per year. And then, obviously it scales up with volume-based discounting from there. Yes?
What kind of parameters is the database optimizing?
Question was, what parameters does the database optimize? It really looks at a few things. It looks at the data that's coming in. So we're looking at sort of the variety, velocity, the classical 3V theory of data, right? We also look at the work that's being performed. Is it read heavy or write heavy, big transactions, small transactions, a lot of inserts, or what's the mix of the work? And then we also look at the cost of various resources in the machine in real time. So is the CPU have spare cycles? We might slot CPU computational heavy work in. If the disk is really expensive to use right now, we might defer flushing cache for a period. If memory is really tight, we might flush sooner, as an example. So you're really looking at the work, the data, and the cost to use various resources and making scheduling choices on a very, very small time base, and that really escalates the throughput of the system dramatically. Yes?
Does the system alert you to bottlenecks?
It does have a logging system which does monitor things like memory pressure, disk utilization, things along those lines. But the whole goal, the premise here is it's a fly-by-wire system. We will react, and it's in machine learning, so if we are doing certain techniques and they're not yielding the benefits, we'll stop doing and try different benefits.
Right, but if you're hitting a hard wall with storage or with memory.
Yeah, absolutely. So if you do have a situation where you are up against a hard limit, we do log that, we do generate errors, and that can be tied back to reporting systems. Yes?
In terms of scalability, how does it stack against AWS or Azure?
Great question. So I'm going to let the cat out of the bag a little bit. We just completed a benchmark study that InfoWorld performed, comparing us against AWS Aurora, which is their kind of homebrew MySQL alternative. And I think transactionally we were probably 2x to 3x faster than them on transactions. And on the analytics side, we were about 11x faster, which is pretty cool when you think about it. We're running on generic EC2 hardware versus Aurora running on highly optimized Amazon infrastructure. So it's pretty cool. Yes, down there.
Yeah, you talked about NoSQL, right? And comparing NoSQL. So what kind of scaling you run into the cat theorem, and you can't be consistent and all that, right?
Sure.
So what is? Can you talk a little bit about what's what you've done? What is the method?
Sure. So there's two aspects. The question was regarding scale up and hitting limits supposed by the cap theorem. So our solution today is a scale up solution. So our idea here is you've got a MySQL system. You can take us, drop us in, and you just got a lot of headroom. Potentially an order of magnitude, better capacity, depending on your workload. Any replication you're doing will go faster, but we are not a native scale-out play today at all. Toward the end of this year, we'll be introducing some scale-out technology, but the idea here was to be pin-compatible, so to speak, with MySQL, and be compatible with that entire ecosystem and tool chain. So we don't kind of break any of the rules there, but our goal is to scale up and maximize the resources you're paying for, and at the same time reducing the latencies involved in the workloads. Yes?
In the unlikely event that a customer doesn't like your system after using it for a while, how difficult is it to back out of it?
Great question. So if you decide you don't like it, can you go back? So putting any performance benefits you enjoy going away from an actual mechanical point of view, and bore you guys with DBA speak, but because we're MySQL compatible, we appear essentially as a new storage engine in MySQL speak. So from a DBA's point of view, all you do is say alter table engine equals D, and all your data migrates over. You don't like it, you say alter table engine equals it all migrates back. So it's that simple, or you can do other methods like dump and load, but we don't require any schema changes. The data doesn't change with respect to any proprietary formats, so it's very easy to go back and forth. Obviously, bigger data sets take a longer time to convert, but there's no lock-in, there's no proprietary hooks that we've kind of tied you into. It's not Oracle. Right?
That would be a big sales point, I would think.
Yeah, absolutely. Question in here?
Yeah, can you work with other DB schemas, DB platforms?
So today we work with all of MySQL schemas and platforms. We support triggers, stored procedures, all the various data types, and transactional workloads, all 4 isolation modes. So all the geeky hard things that MySQL does, we do too. And that was the idea, that you could drop into any MySQL environment and get the job done.
Thank you very
Right.
much.
Thank you guys.
Thank